2.5. How many terms in the series are divisible by 4? Now I've written out most of the problem for us prior, just to save some time, because this is just expanding our already given series. But let me walk you through it. So initially, it's not very obvious how on earth would we find out how many terms in this series would be divisible by 4. So this is a good example of recognizing that we're dealing with sequences and series and probing the problem and prodding it and just looking for patterns and looking for repetition, because ultimately that's the section we're dealing with. In fact, it's always good to look for repetition in any problem. So what I did initially, and this is how I would have solved it, there are other ways to look about this, but that will be covered in another video. But I would have rewritten the series, and I have here 2, 9, 16, 23, and I just keep adding 7, and then when I got to about 12, 14 terms, I then inspected everyone and had a look if I could see a pattern of which ones were divisible by 4. And I noticed that 16 was divisible by 4, 44, 72. And then there were a couple that weren't. So then I thought, wouldn't it make sense if I wanted to find all the terms in this series that are divisible by 4 to the 251st term, I could make a new series with the terms I have over here that are divisible by 4, thus generating a new equation or formula to find out how many are divisible by 4 in the series. So what I mean is, let's write the terms we have. We got 16, 44, 72, etc. And this is enough (251). This is enough information to give us a formula. Our first term is now 16. Our D is 28, if I recall the common difference. Let's check that. 44 minus 16, 28, yeah. And we are going up to the 251st term, and the value of that we have calculated previously. So it's all building up on one another. Here we go. 1752 is the 251st term. So T251, 1752. And you'll notice we have all the information to find how many terms, so AN, sorry, just N, how many terms are divisible by 4. That will just be how many terms we have in total in this new series. So just to reiterate, I decided to probe the question by expanding out the series a bit more. I collected the terms that were divisible by 4, and I've generated a new series to now do the exact same thing we've been doing in the other questions. So let's continue. We know our formula to acquire the nth term. If we have the nth term value, would be the first term plus the common difference. We don't know how many terms we have in total. That's what we're trying to find. And we know the last term is equal to 1752. Let's just write it as AN for now. Now it's just a matter of subbing in 16 plus 7, oops, that's the previous question, 28, the common difference, n minus 1 equal to 1752. And now it's just a matter of solving for n. So let's do that. Get your calculator out. 1752 minus 16. 1736. 28n minus 28. 28n equals 1736 plus 28. 1764. N is equal to, divided by 28, 63. So what we have shown is that in this new generated series, we have a total of 63 terms to the 251st term in our original series. So it's a little bit trippy, you could say, because how would you have known to generate this new series? It's just a matter of probing the question. I recognize that I needed all the terms to be divisible by 4, so I expanded out to look for a pattern of any sort. Decided to instead create a new series to the 251st term, consisting of 16, 44, 72, and then made a new arithmetic series formula to calculate the nth term to the value of 1752, thus giving us how many terms in the original series would be divisible by 4. It's quite a tough question actually, because if you go down the wrong road, you might not have enough time to finish. But if you just probe it enough, you can formulate a good idea on what to do. And a good start would be to look for a pattern or try generate a new series. And that is the question solved.